This is section 5-4, complex numbers. Our objective today is I can simplify problems with imaginary numbers. The imaginary unit I is defined to be I squared equals -1. The number I is the principal square root of -1. In other words, I is equal to the square root of -1. The commutative and associative properties of multiplication hold true for pure imaginary numbers. You can calculate any power of I by knowing only the first and second powers. So, what we want to do here, we have I to the 10th. We want to write anything we're trying to figure out what it equals that is I raised to a power. We always want to start off with I squared because we know what I squared is equal to. So if I have I squared, I know that I'm going to have an exponent of 5 on the outside for it to equal 10, because 5 times 2 would give us 10, so that would give us I to the 10th. So I squared, all raised to the 5th power, is equal to I to the 10th. So if we rewrite this, we know that I squared is equal to -1, so I'm going to replace the I squared with -1, and now I have -1 to the 5th power, which is equal to -1. For I to the 11th, we're going to do the same thing. We want to start off with what we know, so we want to start off with I squared, and we want to get it, since this is an odd number, we can't put anything on the outside that will get it to exactly be I to the 11th, but the closest we can get is I to the 10th. So I want to put a 5 on the outside, and that'll get us to I to the 10th, but it won't get us to I to the 11th. We need one more I, so I'm just going to multiply by I, and then I can rewrite this. So we know that I squared is equal to -1, so I'll end up with -1, and then of course -1 will have -1 to the 5th times I, and -1 to the 5th is just equal to -I, or -1, excuse me. So then we have -1 times I, which equals -1I, or just -I. Either way you want to write it is okay. On the third example, I to the 12th, we'll go ahead and start off with that I squared. And we know if we put a 6 on the outside, because 6 times 2 gives us 12, we won't need to stick another I on. So we know that I squared is equal to -1, and then -1 to the 6th power is equal to +1, which is our final answer here. And then I to the 97th power. We'll start off by writing I squared, and we'll go ahead and raise this to the power of 48, because that's going to get us all the way up to 96. We'll have to tack on that extra I to get us all the way up to that 97 exponent, and then we can rewrite this. So we have -1 to the 48th power times I, and -1 to the 48th power is going to give us 1. So then we have 1 times I, which is equal to 1I, or you could write just I. When we're looking at taking the square root of a negative number, we're going to do the same thing we would do as if we were taking the square root of a non-negative number. The only difference is, right at the beginning, for the negative that we have here, we're just going to go ahead and take an I to the outside, because we know that the square root of -1 is I. So I'm just going to go ahead and write I to the outside to get rid of that negative. So I have I and then the square root of 27. And now I'll break the 27 down just as I would any other time I was taking the square root. So remember, I'm looking for pairs because this is a square root, and I have one pair of 3's that can move to the outside. So I'm going to end up with 3I square root, and then remember, anything that's lonely that doesn't have a pair has to go back inside, so a 3 is back on the inside. So our final answer is 3I square root of 3. Same type of deal with the square root of -216. I'm going to go ahead and take an I to the outside so that I just have the square root of 216, and then I'll break my 216 down. So I have 108 and 2. 108 will break down to 54 and 2. 54 can break down to 27 and 2. 27 can break down to 9 and 3, and 9 can break down to 3 and 3. So now I want to look for my pairs. I've got a pair of 3s, a pair of 2s, and then I have to write what's lonely back on the inside. Remember, my I is still on the outside as well. So for the lonely guys, I have a lonely 3 and a lonely 2 that has to be rewritten on the inside. And now I can just simplify this. So 3 times 2 is 6. So I have 6i on the outside and 6 on the inside, and that's going to be my final answer. When we multiply imaginary numbers, this is actually going to work the same way as if we were multiplying regular numbers. The only difference is we now have new knowledge in that I squared is equal to -1. So let's go ahead and look at our first example. We have -5i times 3i. -5 times 3 is -15, and I times I is I squared. So we have -15i squared, but remember we have that knowledge that I squared is equal to -1. So we'll go ahead and rewrite it this way, -15 times -1, which is just positive 15. Now make sure you simplify these all the way, changing the I squareds to -1, or it won't be simplified all the way. On the second one, I'm just going to go ahead and take my i's out, so I have I square root of 6 times I square root of 15. And that got rid of my negatives. So now I can just go ahead and multiply these together. I times I is I squared. Square root of 6 times square root of 15 is square root of 90. Then I can break my 90 down. So I have 10 and 9, 3 and 3, and 5 and 2. So I have a pair of 3's that can come out. So I have 3 I squared square root of 5 times 2 is 10. And then remember, my I squared turns into a -1, so I have 3 times -1 times the square root of 10, which gives me -3 square root of 10 is my final answer. So let's go ahead and look at example 3. And we're actually trying to solve for x in this case. So I'm going to start off by subtracting 256 from both sides, so working this just as I would a normal equation. So I have 4x squared is equal to -256. I'll divide both sides by 4. So I end up with x squared is equal to -64. And then I'm going to take the square root. So now I know that if I take the square root of a negative, I'm going to take an I to the outside, and I'm going to break down the 64. So in this case, 64, we know the square root is 8, so we have nothing that's going to be left on the inside because I have a pair of 8's that comes out. So I have I times 8 on the outside, and since we took the square root, we want to make this plus or minus, and we have 8i. I could leave it as I times 8, but 8i is how you'll see it written in mathematical notation. We can also add and subtract complex numbers. Now, the biggest mistake I see when I teach this is that a lot of students want to FOIL these. You would FOIL if there wasn't a sign in the middle, but since there is a sign in the middle, we're just adding these together. So really, this is just going to be combining like terms. So I can actually rewrite this without the parentheses. So I have 5 minus 7i plus 2 plus 4i. And then I can just combine. So 5 plus 2 will give me 7. And -7 plus 4i will give me -3i for my final answer. On the second example, I can rewrite it without the parentheses, but remember this negative is going to go to both pieces. So I'd rewrite it as 4 minus 8i minus 3 plus 6i, because that would make two negatives, which would make it a positive 6i. So now I can go ahead and combine like terms. So 4 minus 3 is 1, and -8 plus 6i is plus -2i, or we can just say 1 minus 2i is my final answer. Two complex numbers of the form a plus bi and a minus bi are said to be complex conjugates. The product of complex conjugates is always a real number. So if we go ahead and look at this example, this is where we're going to be foiling. And the reason we'll foil here is because there isn't a sign in the middle. So we know that we're multiplying. So 2 times 9 will give me 18. 2 times negative 3i will give me negative 6i. 4i times 9 will give me 36i. And 4i times negative 3i will give me negative 12i squared. So we can go ahead and combine like terms that we have. So we'll have 18 plus 30i plus negative 12i squared, or minus 12i squared. Either way is fine. But now since we have that I squared, we know we can simplify that, so we'll go ahead and do that. So we're going to have plus negative 12 times negative 1, because I squared is equal to negative 1. Negative 12 times negative 1 is positive 12. And now we can go ahead and combine like terms again, because we can combine 18 plus 12, which will give us 30. So 30 plus 30i is my final answer. For the second one, I'm going to do the same thing, so you can see this process again. We're foiling, so we have 6 times 9, which is 54. Our outside will be 6 times 2i, which is just 12i. Our inside will be negative 8i times 9, which is negative 72i. And our last piece, negative 8i times 2i, is negative 16i squared. So we can go ahead and combine like terms. So we end up with 54 minus 60i minus 16, and we know that I squared is equal to negative 1. So we have 54 minus 60i plus 16. And if I combine like terms again, I end up with 70 minus 60i as my final answer.